Welcome you all. Today we're going to discuss about a linear induction motor. Before going to discuss about a linear induction motor, we must know about linear electrical motors. Okay, linear electrical motors belongs to the special electrical machines category. It just convert electrical energy into mechanical energy of translation motions. Okay, some classification of linear electrical motors are induction motor, DC motors, synchronous motors, including reluctance and stepper motor, oscillatory motors, hybrid motors. Okay, out of these topics, we are using depend upon the applications, we are select the different types of linear motors. Okay, what are the applications? Conveyor systems, theme park, traction motors control, cranes, baggage handling, rapid transportation, and low powers also robotics, gate control, guided trajectories, stage and certain movements. NASA also envisions the use of such a motors for launching spacecraft in futures. Okay, this slide indicates as a linear induction motor. Okay, first of all, we're going to discuss about constructions of linear induction motor. Linear induction motor is nothing but it is a conventional development of three-phase induction motor. Okay, instead of rotary motion in three-phase conventional electrical motor rectification, linear motion is obtained from linear induction motor. Whenever the relative motion occurs between the fields, the short circuits of conductors current are induced in them, which results we get electromagnetic force. Under the influence of the force, according the Lenz's law, we find out that induction current direction. Okay, in this case, field movement is linear, so the conductor moved in a linear. Okay, the imaginary process of these linear induction motors are cutting, rolling, okay, and sometimes unrolling for the rotary counterpart. Okay, it's having here two important parameters. One is a stator, another one is a rotor. Okay, in this diagram, we are clearly indicates as a stator part, rotor part, at the coil is placed in that particular places. Okay, next. This one is a linear induction motor, clear constructions. To obtain cutting the stator windings along the plane A perpendicular to the primary. Okay, this diagram is focused. The secondary of the rotor of linear induction motor consists of plate copper, otherwise aluminum. Okay, in this diagram we are prefer aluminum plate. Okay, a linear induction machine, it's a simplest form, consists of field system having three-phase distributed winding placed in that slot. Okay, this is a short single primary. The field system may be single or double primary system. The secondary of this type of induction machine normally conducting a plate made either copper or aluminum, in which interactions current are induced. Depending upon the use, linear machine can be one of the three types. One is a short primary. Okay, first we're going to discuss about a short primary. The primary is short, so the secondary is long. This is useful for when the total distance is traveling for very long. Okay, that applications we are primary is strong, secondary is long. This type of rotor, okay, this type of rotor to produce overheating, okay, that is eliminated. This is the advantage of this short primary. Okay, because of continuous movement of the primary over a cold part of the rotor, okay, leaving behind the heating part. In this case, primary moves the secondary or stationary. In this case, primary moves, secondaries or stationary. Okay, next case, short secondary. Vice versa, secondary is short, compare the primary, so primary is long. Okay, this is used for short distance travel. It must be light. Long primary and short primary having some drawbacks in short secondary systems. Large primary is uneconomical and requires long this three-phase primary winding to be covered. Okay, only that part of the primary winding which are adjacent to the secondary and effective at every one time. Okay, in two-field systems, this is another type. One is a short primary, next one is a short secondary, and the third one is a two-field system. In this two-field system, primary system one on either side of the secondary. Okay, we will indicate as figure. It is often as it is minimize the leakage fluxes and avoids magnetic attraction between the moving parts and a reaction rail which exists in either of earlier of two types. Okay, depending upon the particular requirement, either member can be stator, the other being of the motor. Okay, in primary we are prefer for ferromagnetic plate. It's a placed on other side of conducting plate to provide a path of low reluctance to maintain the main flux. The ferromagnetic plate, however, gets attracted towards the primary when the field is energized. Consequently, unequal air gap length results on two sides of the plate. Okay, so double primary system can be used to overcome this problem. That's only we are prefer for double side primary. Okay, the use of motor decides which of the two primary and secondary will be shortened in length compared to the other. The primary is made shorter than the secondary when the operating distance is large, and short secondary is used when the operating distance is limited. Okay, these are the formulas. Okay, linear speed of the primary is proportional to the frequency of supply voltage. It's a directly proportional. So whenever the frequency and supply voltage will be increasing, okay, automatically the output also increasing. The pole pitch of the primary part is laminations to reduce the losses. Okay, here Vs is indicated as velocity of the primary stator. Okay, small t indicated as a pole pitch. Fs is indicated as a frequency of power supply. Okay, but linear inductance motors are asynchronous, which means the secondary travels at a speed lower than the magnetic field of the primary. Okay, the difference in the speed is referred as a slip. Already we know what is meant by slip. Slip is nothing but it is the difference between stator and rotor. Okay, ns minus nr divided by ns, always indicate as a percentage, so into 100. Okay, thank you.